Hi guys, and welcome to a new episode. Today we're going to talk about methods on logging into a Linux machine, either through password authentication or passwordless authentication, meaning you don't need to use a password. So let's jump right in. We have here a Linux machine, which is my current machine that I'm recording on, and I want to connect to another Linux machine. I have here somewhere in my own network another Linux machine that I want to connect to, and the easiest way to connect to another Linux machine is through the SSH command. Well, SSH stands for Secure Shell, and it allows you to do a remote connection to and from another Linux machine. And the command is fairly simple. It's SSH, the username, and the host name. And I'm being prompted to input my password, and if the password is correct, I'm being connected to that Linux machine. As you can see, this is my username and this is the host name of the machine. If we take a look, if I type in host name, it gives me this local machine's host name. If I exit out of that connection and type host name again, you see this local machine, it's called something else, right? So that's a proof that through SSH I have connected to the other Linux machine, and I was able to run commands, do all sorts of stuff, depend on what I need to do. Cool. Now this is fairly simple, right? SSH, username, and the host name, and then you input the password. Now, how about if you don't have a secure password? That can be cracked, right? If someone that's ill-intended could sniff the packages through your network, and it can crack the password if you don't use a high security algorithm to create your password. So in that situation, what we can do, or let's say we don't want to input the password every time we want to SSH into that machine. For example, you have multiple machines that you need to connect to, or you want to transfer file to, because it's the secured protocol to do so. We have SSH to just log into that machine, but we also have SCP, which is secure copy, right? And the command works pretty similarly. What if you don't want to input the password every time you want to copy something from your machine to the remote machine, or the other way around? Well, for that, we're gonna use SSH keys. SSH keys will remove the need for you to input the password every time you want to log into the machine. So how does that work? Well, it's fairly simple. On your local machine, right, the machine that you're doing your job from, you need to check into your home directory. So cd, short for home directory is the tilde character. That will change directory to your home directory, or you can go the long way, cd/home and your username. In my case, this is my home directory. If you have a look, there we go. Okay, in this directory we need to check for a hidden directory called .ssh. Now, to list all the directories, you do the ls command, but ls or list only shows you the visible directories. To see the hidden directories or files, you do ls-a, which stands for all. And as you can see, we see a lot more stuff than before. If we want to see a list that's looks like a list, then we do the ls-l, which stands for long or list. And if you want to see also the hidden files, we add the a argument, right? So ls-la, or you can have it ls-l-a, but you can combine these parameters. And there you have a long list of files and directories in your home directory. Next, we need to search for the .ssh directory, like I said before. and here it is. If it's not, then you'll need to create. And to create this directory, it's fairly simple. mka dir, which is make directory, -p, it stands for create directories. If you provide a longer path like -home, my user, like so, if any of the previous directories like home or tdascal or .ssh do not exist, they'll be created because I use the -p, which means parent. So the command will create the parent directory if it doesn't exist. Alright, now it does not do anything because I already have the .ssh, so I just need to change into the .ssh, and here's the structure. Known hosts are the hosts that you're connected previously from your local machine, so it keeps a track on the remote host that you've accessed throughout time. Now we need to create the keys so we are not obligated to input the password every time we want to connect to a remote machine. To do that, we use a utility called Ssh Keygen. Now if you run the command as is, it's gonna tell you that it's about to generate public and private RSA keys. It asks for the location where the file will be stored. By default, they're going to be stored in your home directory in the .ssh under the name id_RSA. If you want to change that, put another location, you need to input here the full path. So it doesn't work with relative paths. So I need to say home, use your username, some folder, and so on. I'm not going to do that because I like to keep the thing simple. If I hit enter, it's going to ask me if I want to protect my key with a password. In this situation, I'm not going to do that, but anyone who works as an administrator should always protect these with beefy passwords, right? It's going to ask again for the passphrase, and now the key is generated. If we list again the SSH directory, let's do A to see everything. See, now we have an id_RSA and a file called id_RSA.pub, which stands for public. Now this is fine, but usually what I like to do is give a higher density to my key. And what do I mean by that? So I'm going to remove these keys that are created because I'm not going to use those. RSA, and if I want to remove both of the keys without passing in both of the name, I'm going to use a wildcard that stands, which is this star at the end, and hit enter, and it's going to remove both of the files because they have similar names. When you issue the command keygen, you have a few options. First, you can define the type. -t stands for type, and I'm going to choose the RSA. This is the algorithm that is going to encrypt my key. Next parameter is going to be -b, which is bytes, how many bytes the key should have. So in my case, I'm going to put 1496, which is 4 megabytes. Default, just so you know, it's 3 megabytes. Okay, now I'm going to use the beefiest keys that can be generated through this utility. Okay, and that's kind of it. If you wanna name the file something else, you can do -f and then specify the full path and the file name. But I'm not gonna do that. I'm gonna keep it simple. And it's saying generating public and private key, RSA key pair, enter file name, which will be to save the key. So I'm gonna keep it ID RSA. Set a passphrase. I'm not gonna set the passphrase. And now you can see here the size. So that's it. We've created a key, but we're not done yet. we need to let the other system know what key we are going to use. If we look again, we'll see that we have our IDRSA and our IDRSA.pub, which, if you remember, it stands for the public. Now, any encryption system is based on a private and public key. The private key is the one that you keep on your system, and the public key is the one that you share it with the remote host, right, with the other system. The reason we do that is because based on that key, the encryption is going to happen, right? That's the key that will help encrypt on one side and decrypt the message on the other side. And if you're wondering what encrypt and decrypt means, it means that if I try to send a message like I am hungry, while transferring the message from my host to the remote host, it's not going to look like I am hungry. It's going to look like a bunch of gibberish, letters, numbers mixed in together that would make no sense. That's an encrypted message. On the other side, on the remote side, it's going to end up I am hungry, because the remote side it's going to use the public key to decipher the message. All right, so how do we tell the other system that it needs to use this public key in order to decrypt the communication? Well, it's fairly simple, sort of. The command is a bit long, but it's not that complicated, and I'm going to explain each part. Okay, so let's see. We're gonna do cat, which stands for concatenate, which can output the content of a file. The path, so I'm already into the path, so I'm going to do IDRSA.pub. Then I'm going to hit a pipe. This is called a pipe, meaning the output of the previous command is going to be fed into the input of the next command, and we'll see why. Now here we're going to do an SSH, my username, the remote host, and here we need to run a command. The first thing we need to do is create a directory. Remember, we've tested this at the beginning of the video, so make directory, the home.ssh, that's one of the commands that we're going to use. And we're going to link multiple commands together. So basically, once this command finishes executing, the next command will execute, and so on and so forth. So we can write a bunch of commands here. The next part that we need to do is create the authorized keys file, and we'll see what that file is used for. So touch is the command that creates a file, home folder, ssh, authorized keys. Perfect. Now we need to set permissions for this file, so it's not accessible to everyone. Some people will need to access, but not everyone. .ssh, yep, and we need to concatenate the input or the output of this file into the file that we've just created. So that's why we use authorized keys, and that's why we do so many redirection. SSH, authorized keys, and this is it. If we hit enter, it should prompt us for our password. If the password is correct, then it's gonna do all these commands on the remote machine. So this is why we don't see anything. We don't see how it's creating the directory, don't see how it's creating the file, we don't see how it's changing permissions, and how it's adding the lines in this particular file into the remote file, because everything is happening on the other side. Alright, so now we should test it just to make sure it's working properly. And the command, it's the same, ssh my name, remote host 30, and it should not ask for a password if everything was done correctly. And as you can see, I did not have to input the password as I was prompted previously, and on the remote machine it's letting you know that the last login is the current date, the current time, and from where within the network, which machine is accessing. So my local machine, if I do an IPA, this is the remote machine which I'm connected to, and if I exit from that machine and I do again an IPA, this is the local machine. So you can see these two machines are in the same network. Alright, that's kind of it, guys. This is what you need to do to create keys in order to connect passwordless from one machine to the other. I really hope you enjoyed this video. If you have any questions, please leave a comment. It will help a lot if you can click that thumbs up button. Subscribe if you wish to see more content like this, and see you in the next video. Cheerios!